Kamrul, I cannot hear you. Is there any audibility issues? Yeah, now it's fine. Now the mic is fine. Okay.
Okay, sir, you can
So,
start your presentation.
okay, fine. So, good morning, good afternoon, good evening to the participants from whichever part of the world you are. We are to take you through in the next 1 hour through IoT and some potential inventions. Mostly, I'll talk about more about inventions and more about my research orientation on based on the Internet of Things. As we all know that we are hearing this buzzword for almost a decade now, and things have been developed in such a way that every person or every researcher is moving ahead with the uh, discussion on IoT. So I'll go through it quickly. My profile, myself, Dr. Shobik Ganguly. I have been working as an assistant professor in the Department of Electrical and Instrumentation Engineering at Thapur Institute of Engineering and Technology. It is situated in Patiala in India. Regarding my background, I have done my BTech in electrical engineering, MTech in mechatronics, and PhD in the area of system identification and control. Further, I have an industry experience of 2 years and almost 16 years, of which 13 years I have spent in my present institute. Regarding the thesis guidance, I have guided uh, around 28 or 29 master's thesis, mostly with solo supervision, and there are few who are also my co-supervisors in this projects as well. Apart from that, recently we have been our student have been awarded a PhD degree in the area of optimization of renewable energy sources, and two of them are undergoing a PhD under my supervision. Regarding the publication and patents, mostly I'll talk about patents today because as the Internet of Things and the projects related to what we are doing and we are developing, after giving you a brief background about IoT and the concept of IoT and the definition of IoT, we'll gradually move on into the more discussion phase because we expect the audience to be general so that all may not be from a technical point of view. So may not be able to relate the coinages that we are going to use. So mostly I'll try to keep less of a slide and more of a discussion. And regarding the patents which we are going to take up, we are going to discuss about three or four during my presentation as well. So, and maybe that we are expecting few questions. If there are any technical persons, you may put it in the Facebook live session or in the question and answer session. Of course, we can go for some discussion as well. So, first of all, let me tell you about Internet of Things. First of all, how it evolved and what are the different stages. We have divided our lecture into two parts, namely dealing with the fundamentals, and second one is the wireless sensor networks or the sensor networks preferably. So I do feel that fundamentals is good enough for today's discussion, and then we'll go into the some of the innovations that are taking place with in my labs in my research areas as well. But I'll also take into account this thing. We have also discussed this agenda with Mr. Kaushik of IGP that we seem to move ahead with some practical applications or some hands-on training based on IoT because these things cannot be learned theoretically. So we will at certain point of time join hands together to discuss some practical applications or some training sessions on hands-on training sessions on IoT as well. So this is basically an eye opener for you and to explore the topic. And after that, we will go and move on into the next session part. So first of all, in this particular unit, what we are going to discuss the definition of Internet of Things or IoT, which we are calling as a short form. And you will find that there are plenty of Internet of robotic things, Internet of drone things, Internet of energy. All those terms are becoming very popular. These coinages are becoming very popular. We apply Internet of Things everywhere almost these days. So we will first of all define and the technical definition of IoT. We'll try to concise it as per the technical terms involved in IoT. We will discuss shortly the characteristics of the IoT, the different physical layers involved in the design of IoT, and also the logical design part. And then we'll have some discussion on the communication protocols associated with IoT and the different levels and their deployment templates. So basically, first part of my lecture, I think we'll be spending more time on the first part, because rather than hurrying up with the second unit and completing the entire cycle of IoT, because it cannot be covered, of course, in a 1 hour session. So there are several issues that may be there, that may be a part of your queries as well. And definitely, all people who are watching this Facebook Live program may not be from the technical side, they may be from general education background. So I should also give an exposure to the IoT as well. So mostly we'll restrict ourselves to one of the units, 1 or 2 units, and this is not enough. I think we should discuss with Rosit sir, and we should make it a point that these things should take place in a series of lectures on IoT, and gradually, if we move on, there are several aspects that we'll come across uh, of Internet of Things, and we can have some classification. Say, for example, we have a research article on Internet of Drone Things or Internet of Robotic Things as well. So definitely, those things we can take up in separate sessions as well. So, what is basically the meaning of Internet of Things? What we are calling it, that a dynamic global infrastructure. So the emphasis is on dynamic global infrastructure, so global network with self-configuring capabilities based on certain standard and based upon certain interoperable communication protocols. So where there are two things that are mostly common. One is the physical and the other is the virtual, having identities, their existing identities. And when we are talking about the physical attributes and the virtual personalities, using certain intelligent interfaces, and they are being integrated into an information network, and with the help of this Internet of Things, we are able to communicate with or associate with certain users and their environments. So basically, it's a smart way of controlling your appliance, your equipment. Nowadays, you will see most of you are going through certain changes in your home automation, in your home security system, automatic door buzzer or IoT based door buzzer system that we had proposed in one of our uh, ongoing work with respect to the international patents. We have filed already, so it's in process. Maybe, hopefully, we are expecting in a month or so. We are expecting some outcome of it. So things are of that sort. How you communicate with, how you associate with your user, how do you have the physical thing and the virtual thing being closely connected to develop a dynamic global network. So this is how we define Internet of Things, and let me go through the characteristics of Internet of Things. It must be, just as I told you, that I have used few key terms in this. So one is dynamic, the other is self-adapting, the other is self-configuring, interoperable communication protocols. Identity must be unique. So whoever is using this Internet of Things must have a unique identity operated through your mobile phone. Say, for example, I want to regulate my home automation, and I want to use a smartphone to operate all the lights and fans. We have been seeing the different ads in different networks, in different print and as well as electronic media. We are seeing several ads about smartphones, and of how they are able to, how we are making use of the Internet of Things in order to develop certain technologies that will automate uh, our different electrical appliances at our household, several electronic appliances that we are using, such as washing machines or dishwashers or something of that sort. We are into also some work related to smart agriculture. So we have tried to develop a certain IoT based facility to detect any vegetation or detect some geographic configurations or something of that sort. So definitely it is a part of each and everyone's life these days. So we are going about different security systems as well, and IoT is also being used in the defense application. So we proposed over here some military applications, some defense related applications with respect to the IoT. So of course, it should be integrated into an information network. So it is an integrated network. It is a dynamic model. It is a self-configuring model that we are trying to propose, having unique identity of the user and interoperable communication protocols. So communication is so communication is equally essential. How do you communicate? What are the different communication protocols? So obviously, I'll at certain point of time definitely discuss with certain communication protocols. Physical design of IoT. So what it is physically, what kind of devices that we are exchanging data with, and with some connecting devices, some applications directly or indirectly, how they are connected with, how we are collecting the data from the other devices, whether we are making use of any sensor or not, how do we process that particular data locally, and how to send that particular data to some centralized system or any cloud-based application, definitely for processing of the data. And of course, when we are performing some tasks locally and other tasks within the IoT infrastructure based on some constraints. The constraints may be temporal, the constraints may be some space constraints as well, because huge amount of data, and you'll be glad to know that data analytics is also becoming a part of big data analytics is also becoming a part of this internet of things these days. So we'll gradually show you the roadmap that how IoT have been developed between 2000 to 2020 and onwards, going onwards. How is the roadmap of IoT at certain point of time? We are going to discuss that also. So this is about the physical devices that are physical design of IoT, that it refers to certain IoT based devices which have some unique identities and can perform remote sensing and actuating and have monitoring capabilities as well. So this is about the physical design of IoT. Now, looking at, I'll not go through the technical part too much because I expect my audience to be general in nature. So I'll brief you about some of the processors or connectors, connectivity. How is the connectivity being established? How are the memory interfaces being taking place? How are the audio and the video interfaces being taking place? What are the different types of IoT IO interfaces that are there for sensors or actuators? What are the storage infrastructure? What is the graphics that we require? Support of graphics that we require. So that's why I thought that I should reflect it through some diagram so that we can have a discussion with the help of a diagrammatic view the different IoT devices, and it may consist of several interfaces for connections to other devices, and those devices may be wired or those may be wireless as well. So IO interfaces are there for the sensors. So we have to measure, or we have to take certain data from the sensors, so for which the IO interfaces are there. Interfaces are there for also the internet connectivity, as we have shown it in the figure with the help of connectivity. It may be USB host, or it may be through Ethernet or internet as well. Memory and storage, definitely, when we are dealing with whether it's a cloud storage or whether we are going for simple memory storage only. So storage devices are also a part, and of course some audio video interfaces. So if we are to communicate with through some audio interfaces or through some video interfaces as well. So, of course, you can well imagine that a huge amount of data will be involved, and definitely the use of cloud interfaces, the storage devices in the form of cloud applications are also a part. So, it is not these days Internet of Things alone, it is Internet of Things plus sensor data and your connectivity issues, some communication protocols, some interfaces that we have, memory interfaces, some graphic designs of graphic interfaces are there. Some processor is going to process the data and send some signal uh, uh, to the output side. So of course, just as I was mentioning, I'll discuss only the protocols. I'll name the protocols rather. So there are different types of layers in which the communication protocol of your IoT works. So mainly classified as application layer, which we use of making use of your internet, or which we call as HTTP, and other web sockets are also there. XMPP is also there. So what is basically the application layer is the interface that we make. Apart from that, we have the transport layer as well, involving TCP and UDP. We have a network layer as well. So there are several network layers that are available. Link layer is also a part. So these are the different things where we need to take into account certain IEEE standards or IEC standards as communication protocol standards. So over here we'll find over here some nomenclatures are there in terms of 802.3 or 802.11 or 802.16 and likewise. So basically dealing with some certain communication protocols. So these are the things. It is basically I told you that is a fundamental that we are doing, and we are expecting a general audience. So we are not going to take into account each and every part of the communication protocols, and all those details will be definitely be there in some series to be followed. Application layer as well, we uh, have a detailed picture of the different IoT protocols, right? So let's come to with the layering that we have made about the different parts of the IoT devices. What we are finding that it's a logical design, and mostly involves application, services, management, communication, security, as well as at the device level. So basically, your IoT system will consist of a number of functional blocks, which we have shown over here. It depends. Sometimes we work on the application front. Mostly we are working on the application front, or mostly we are developing some devices, or some security issues are also a part of your IoT based systems, and as well as some communication protocols are also a part of this system. So, logical design of an IoT, it will refer to an abstract representation of the entities and the processes without going through into the low level specifics of the implementation. So, basically, going to we are going to have these sort of applications. So, a few researchers works on the security aspects of your Internet of Things. We work with the communication protocols. So we know researchers working on the communication protocols. We know researchers who are working on the security aspects. Some working on the management issues, and some mostly me and my group are working mostly on the devices and the application part. Because being an engineer, we require to hit upon the latest applications, or think about new applications where your IoT devices can be being made use of. So this is basically a road map that pertains to the journey of IoT, and here we will take into account one of the important things what we call as a radio frequency identification. So RFID tags for facilitating routing and inventorying, or even loss prevention. Sometimes in the cards you are getting some RFID chips as well. So things are of that sort. So if we definitely are moving ahead for supply chain helpers. We are going for some vertical market applications as well. We are going for ubiquitous positioning, some locating people or objects. Also, even animal tracking is taking place through IoT. Your teleoperations or your telepresence also being monitored and controlled by different dispersed aspects, and where we call as physical world wave. So definitely there are journey is you may see over here from the roadmap is usually you'll see that what is the technology reach and what is the time frame that it took, and for the market is very much dynamic in nature with respect to the IoT issues. So obviously we call it a very wide amount of research or diverse domains have plunged in, from electrical side, from communication side, from computer background. People have plunged into the Internet of Things, and they're exploring and they're developing new concepts each day, and they are developing some devices. Few are working on additionally in terms of Internet of Things. They are going for Internet of Drone, they're going for Internet of Robotics. Like these coinages are very common. So we have contributed two book chapters based on Internet of Drone and Internet of Robotics. So important thrust areas that you may look out for, and you may explore further to get the relevant research ideas. So we will shortly discuss about some of the enabling technologies. We have already mentioned about radio frequency RFID. So it is basically an identification system based on your radio frequency transmission. So the diagram is of course self-explanatory, and we have the different types of a reader and database and tags being associated. So we'll talk about tags more and often, and what kind of tags are there, RFID tags that are there. And since 90s, mostly RFID systems are widely used. So of course, you may see over here some coinages, some technical terms that are being used. Definitely some transceiver, which is controlled by usually microprocessor. Nowadays, it is controlled by microcontroller as well to gather information from an RFID tag. So basically working on the radio waves to transfer data from the tag to the reader. So another system that we call as the database. So we are gradually moving on into the cloud-based system. So storage of data, how to store the data, where to store the data, how to minimize the transportation of energy, and something of that sort are also thrust areas of research these days. So here you will get a brief idea of a block diagram representation, that how are the data being sent. So data direction are bidirectional. So of course, data flows from the sending end to the receiving end and vice versa. We have the clock, we have the energy being supplied from the application on the server, or you have the block diagram for the RFID reader, as well as the transponder, which will contain the tag or any contactless card as well. So we are moving on gradually for the contactless cards. So definitely some work or some research articles you may follow, and to get an idea about that how we create your RFID tags or your contactless cards. So previously there was a chip-based card, and gradually we will be moving towards contactless cards. So this is a development which has taken place in recent times. So obviously, some of the application areas, say for example, you want to track your asset, you want to control your inventory, you want to control access to the confined areas. You are to track any person, you are to track any animal or any object as well. It is being used for supply chain management. ID batching is also there. You can have your identity proofs as well of your institute, of your employees. Likewise, so counterfeit for forestalling, this is mostly used in the pharmaceutical industries, and sometimes you also need RFIDs applications in to unlock your car door, your automatic deduction of payment from the booths, and also building access systems as well, payment cards, of course, student identity cards, and just as I told you, even passports as well. We have the RFID proofs, RFID tags being attached. wireless sensors as well as the mesh network. So obviously, we will take a few minutes out of you, and we will discuss about RFID tags as well. And we will also shortly discuss about the sensor networks and the wireless sensors as well. So these are some of the communication protocol standards applicable for different frequency levels. So we'll have over here low frequency tags, we have the high frequency tags, and we have the ultra high frequency tags as well. So obviously maintaining certain protocols or certain ISO specifications, we have over here the standards as ISO. So different ISE protocols are being followed. Mostly we use the low frequency tags for animal tracking. Smart cards make use of high frequency, and your logistics or other items management which we do with the ultra high frequency. So in order to guarantee your interoperability, you require these communication standards. So of course, you are hearing certain new terms these days, Zigbee, Wi-Fi. All these terms are inherent part of your network. So some communication protocols are also associated. So over here we have given IEEE 802.1, 2.11b. So these are the protocols you may go through if you take interest and go through. And you may definitely go through in different parts of the communication standards associated with RFID networks. So of course, more detailing is there. Of course, you need to know the frequency band, which your low frequency band or your high frequency band or your ultra high frequency band will operate, or even your super high frequency bands are there. So some applications are related to telepass or ports or something of that. So we have discussed already these applications, and you can have a glimpse that where it is being applied for smart cards, where we make use of the electronic documents, where we have the electronic money. Some baggage sorting is there, so where we require your applications for supply chain or items management, or where we need to trace or track any animal, any asset being tracked, or any access control that is being provided, which we normally use using the low frequency model. So we have done an access control part regarding theft in the houses, and we worked upon on it using the low frequency networks. So passive tags, these are used, are mostly these are common due to their low cost involved. We require a chip, and the tag identification code storage is there. Converter of a reader energy in tag feeding, and so these type of things are usually available in plastic form or in paper form or other forms as well. So you can see over here tag which is given of UHF AD223. So this kind of a tag is there. It is being antenna is also sometimes designed to collect as much energy as possible, or chip feeding and communication tag or identification tag. We have shown over here some high frequency band and ultra high frequency band antennas over here. So antenna is also an important series of discussion. Those who are coming from communication background or electronics and communication, those who are studying or doing some research areas, they are working on these loop antennas and the dipole antennas. So where it involves some inductive coupling or some electromagnetic propagation as well. So these type of things they are taking place. You can take these terms, and each individual term you can look back. You can have a look, because there are several terms that I am using, several coinages of I'm using. Of course, you cannot get it within a day's time. So of course, you can explore each individual field, and you'll get some success stories, some innovations, some inventions that are already taking place in the past 5 or 7 years down the line. So definitely, when we talk about semi-passive and active tags as well. So you may see from the figure itself that where is the control unit being there, where is the memory being connected, where is the transceiver, and all of these features are there. Battery feeds chip and sensor, of course, it requires some supply or energy for the sensor or the temperature sensor or the humidity sensor to work. passive ultra high frequency tags that are there. Antennas have been designed to maximize the backscattering power and also saving of power to batteries being switched on with a proper reader signal. So it costing around few euros, but definitely worth it. And we have also the active tags as well, working in the area of ultra high frequency and super high frequencies as well. So cost will definitely differ between semi-passive and active tags. So depending upon the users, depending upon the applications, mostly you can have it. So low frequency tags, some of the low frequency tags and their applications that you may see over here, some tags being there on the cow's ear. So ear tags are also a part. Animal tracking, we usually do it with ceramic cover in the animal stomach so that we can get it. Some door locks that we have already mentioned. So that includes the inductive coupling based, mostly passive tags. So working at the frequency ranges are also there. Say working at few kilohertz, and so it is a low frequency tag in our respect of communication. Some high frequency tags are also there, like in the smart cards you are using these side of credit cards or smart cards or sky pass, something of that sort. In clothing also you'll come. In logistics support you have the barcodes and all those things. Smart levels are also becoming part, so obviously it makes use of the inductive high frequency tags. So these are some of the examples that we may quote of where we find the use of internet of things. And when we talk about internet of things, there are some sensors, there are some storage requirements. So of course we will discuss at certain point of time about the cloud computing based applications and some of the wireless sensor network part. So another frequency tags which we call as ultra frequency tags, which are used mostly in the logistics. They are uh, used mostly in the electromagnetic propagation, passive and active tags ranging between 2 to 5 meters, and data rate is up to 640 kbps. So these type of metallic tags, this type of logistic tags are also a part that you are already accustomed it. You are already a part of IoT or Internet of Things or Internet of Energy. Knowingly or unknowingly, you are always a part. A little bit of history to know about that, how the supply chain management works, or how your internet of network of bits work, and how is the manufacturing sector or the retail sector or the consumer sector or the disposal part is being there, how we reach from the raw materials to the consumer end, and how is it being computed. You can give a brief overview about the technologies being developed. So just to give you a flavor that how we are looking into the history of IoT with respect to the supply chain management, with respect to internet network of bits. So once again, going to at any time connection and any place connection. So what are the different terms or terminologies that are being involved, both indoors as well as outdoors, and what is human to human interaction, not involving any PC, and human to thing interaction using generic equipment as well, and thing to thing, so T to T. So these type of coinages have come up very recently, so you can have a go through regarding what kind of research that are taking place, what kind of exploration are taking place with human to human and human to thing and thing to thing. So these type of coinages deal with any place connection and any time connection will involve whether it is on the move or whether it is outdoors or whether it is indoor, away from the PC or at the PC, what we are doing it, whether it's a daytime or whether it's a night time. So it is related to the time connection. And of course, when we are talking about that connecting human being with Internet of Things or human to thing connection or thing to thing connection, so how will I operate? So that will involve any place connection as well. A little bit of connecting the things, connecting these new objects will obviously raise many questions. Of course, what are the questions are there? What is the connecting technology? Definitely, we have been discussing about the different connecting technology. What are the communication protocols? What are the interoperability? between the different objects, what is the communication model that has to be followed, what is the possible interaction with the existing models, and what is the choice of the transport model, the addressing, the identifying and the naming, and as well as the security and the privacy of it. So less we will talk about security and privacy today because I have not kept it in my slides as well. Depending upon the time or the access that we get for the discussion. These type of things are there. What is in store when we are dealing with any animal tracking system? What are the movable objects? Or when we discuss about inanimate objects, like say for example door locks or car buzzers, or door buzzer system that we are designing. So these sort of things definitely will involve certain objects, maybe fixed objects, maybe movable objects as well. So mostly in animate things, we go on with movable objects, obviously dealing with population or group or people or animals on anatomical parts, even cells, DNA, etc. That is also movable as well. So it will involve some movable categories, or depending upon which we have the size, complexity, everything that will be determined. And apart from that, if we are discussing about assets, we are discussing about some information point, we are discussing about certain buildings or certain industrial plants, some machineries, some transport systems, some large containers or some unit loads, some transport units, also some packaging technique or some package devices that we are operating with, maybe with mobile phones or smartphones or personal digital assistants, which we call as PDA. So these type of things, mobiles and pocket PCs as well. So definitely, which objects will be movable, which objects will be fixed, that will be dependent, and also whether those objects will be inanimate or animate as well. So apart from that, I'll go through the IoT-based identifiers. We have three different identifiers as we are discussing today. We have object identifiers, we have communication identifiers, and we have application identifiers as well, which we call as IDs, object identifiers or object IDs, or communication identifiers and communication IDs, or application identifiers as well as application IDs. So what they exactly mean and what we are going. So we have to identify uniquely certain physical or virtual objects. Where we do that, we call it object identifiers or object IDs. We give a certain assignment to the communication identifiers, where we need to identify uniquely the devices in the scope of communication with other devices. When we are communicating with different devices, including the internet-based communications, definitely the communication identifiers will be playing an important role. Apart from that, we have the application IDs, which are used to identify uniquely the applications and the services that we are offering. So this is how the things works. We have the different IDs and their corresponding examples, IPv5, V6, these sort of things. Object IDs, you may find making use of your OID or CID or URL, even some handle numbers, some DOIs, even. And apart from that, the application IDs will definitely involve the URIs and the URLs, especially. So these are some of the things that we may discuss, that M2M communication or M2 uh, human interaction interface with mobile, H2M communication. So these sort of things, or these sort of frameworks are already there. I think another diagram is also will help you to make things clear, that how you are communicating with any cellular network, or whether you are communicating with a Zigbee network or with a Wi-Fi network or something of that sort of WiMAX network as well. So depending upon your application or what we are dealing with, what kind of a machine we are dealing with, whether we are doing the application for a door buzzer system, or whether we are doing the application for a door lock for a car, something of that sort. Depending upon that, we have the machine to human interaction, machine to machine interaction, and likewise. So here is some of the just to make you a glimpse of idea that how are the devices being connected, and how we are making certain architectural point of view, that how they are communicating with each other, or how your operating platform will be what is the client application, where is the M2M gateway, capillary network, and all those things. You can have a glimpse of it as well. So these are some of the applications of M2M network which we have shown, or M2M architecture which we have shown, machine-to-machine architecture that we have shown. It is being used in the automotive, so for passenger vehicle or anti-theft or recovery, any monitoring, any maintenance, or any safety or control equipment, or any entertainment. It is also part of transportation as well. Fleet management, asset tracking, all those things in utilities and in different energies. We have the smart metering. Just as I give coined a term like Internet of Energy, smart grid is also a part of electric line monitoring, or any gas line monitoring, or any water line or pipeline monitoring. So these type of applications you may get in the form of utilities. Security issues are also there. Definitely, we have worked upon home security monitoring or surveillance applications, some fire alarm, some medical alert, some police alert, or something of that sort that you may think of. Healthcare is one of the important things with COVID. Definitely, healthcare applications have improved tremendously, and we are having a remote monitoring system being developed, and uh, healthcare is our telemedicine applications have mostly improved with IoT applications. So smart healthcare, which we are calling these days, are an important feature in which IoT is being applied everywhere. So some other issues related to that. So definitely some handheld devices, some terminals or something of that sort, some vending machines as well. Where your M2M or machine-to-machine interaction is taking place. Kamrul, I'll request you to stop for just a minute or so that we move on to the next unit, and I'll put a break. You can put me on backstage, and 2 minutes I'll have a water break, and I'll be back with you. Let me go into the second unit. I thought that I should not discuss it, but we'll also give you a flavor of sensor networks before we finally move on into the applications. Of course, we had been discussing. I have not put it in any slides on any diagrams because few of them have been granted and few are in the filing stage. So, of course, we will going for some discussion on sensor networks because it will involve some collection of data which where for which we require some outline of wireless sensor networks as well. So sensor nodes, sensor communication architecture or sensor communication protocol, and something about operating system and different types of simulators that are involved or emulators that are involved, we will shortly discuss. And then when we can go in for the discussion session where I'll expect some good amount of question, a good amount of discussions on the apart from the IoT or Internet of Things. Uh, Basically, it consists of a transducer. So what is the purpose of using a transducer? It will convert any physical phenomena, be it some mechanical force, be it some heat or light or any motion or vibration or sound, into an electrical signal. So sensor is an important part of your sensor network. Apart from that, you have a sensor node, which is also basic unit of your sensor network. It will contain some onboard sensors, some processors, some memories, as well as some transducer as well. So apart from that, we can go in straight away into some applications uh, where we can make you understand through some applications or surveillance of your battlefield or monitoring of your forces or equipment or ammunitions. So some military applications we have conceptualized an Internet of Things based robot for defense applications. So how will it fight in the battlefield, based upon which, or how will it prepare yourself for a battle. Some applications related to nuclear or biological or even your chemical attacks are also there, which has to be assessed, which has to be monitored. So some battle damage assessment must be there, which can be a part of your wireless sensor network as well. So these type of applications that you may think of, even your forest fire, which is very common in the Australia and other continents. Definitely, forest fire detection is another important application area where this wireless sensor network can be utilized. Some prediction and detection of flood. So prediction is also equally important. It is a very important role. We are having the use of internet. We are having the use of your AI-based prediction models and flood detection, precision agriculture. Definitely, when we are talking about smart agriculture system or smart farming system, definitely we have been able to make use of certain IoT-based applications with your agriculture can be smartly be managed. Apart from that, we can go in for water and air pollution controlling or monitoring being taking place through the wireless sensor network. So huge amount of data is being involved when we are looking for environment applications, and of course it will involve the cloud-based applications as well as uh, your big data analytics, which will play a very crucial role in the IoT based applications. Apart from that, some health applications, definitely telemonitoring of human physiological data, tracking and monitoring by doctors and also patients inside a hospital. Some drug administration also in the hospitals are taking place through the use of wireless sensor networks as well. So just give you a flavor of what are the different application areas rather than going through it technically. Apart from that, we have been discussing earlier also in smart home and office automation system, smart environment, because we are having the concept of smart city, we are having the concept of smart villages as well in different aspects. Uh, just a minute. So we are having home and automation, office automation system, smart environment. We are having some office applications as well. Wireless sensor networks are everywhere, and of course, it's a smart part of your IoT-based systems as well. Some automobile applications or automotive applications, definitely some robotic applications will be expecting. We are expecting some reducing of wiring effects. We are reducing the measurement in chambers and rotating parts. We are having some remote technical inspections being carried out using the wireless sensor networks, as well as some conditioning monitoring. For example, at a bearing, we need to monitor even the conditioning monitoring of power and distribution transformers are also an important application area in the field of electrical engineering as well. So these type of things are taking place. We have the wireless sensor networks. We have different applications in defense, in healthcare, in automotive applications, in environment applications, in smart grid as well. We are having some more detailed diagrams over here. What are the different sensors that are being involved? What are the different subsystems that are being involved? And every term you are trying to understand that there are several sensors and subsystems or CCUs are there to monitor and to check the speed, to check the brake pressure, to have the suspension, to check the ABS based systems regarding the traction system as well, regarding the emission system as well. So these type of applications you may think about, and you may work upon. And of course you cannot explore all the different areas. This is just to give you a flavor for the different audience. And some commercial applications are also there. Some environmental control in the office buildings, we have the zero energy buildings or something of that sort, where internet of energy and smart metering are being used, advanced metering infrastructure. It is also a new coinage in the area of those who are working on energy and power system applications as well. So detecting and monitoring of car thefts, definitely. We have worked on the detection of a door waiting at your doorstep, or is trying to nurture your locks or something of that sort. You cannot at home. Even if you get a message alert, and you will immediately inform the police, and for which you can do using a smart IoT based system or door buzzer system, along with theft detection system as well. So managing inventory control, this is equally important. And vehicle tracking and vehicle detection is also an important part, which is played by the police and in the smart cities, as well as in the different smart villages as well. So these type of applications are coming up. We are definitely on the way, in right track to work upon several conditions. Few factors definitely are there that influence your wireless sensor design. So of course, some fault tolerance capabilities, for which multi phase motors are being used, some scalability issues. Sometimes you need to have adequate infrastructural issues, some production costs associated, some constraints with respect to the hardware as well, some sensor networks topology, and some environments as well. So transmission media and some power consumption is also associated uh, uh, with the wireless sensor network design as well. So these are some of the sensor nodes. You may physically see these type of things. So visualization is also equally important rather than going through the application area. So thought of introducing you different sensor nodes. It's a crossbow sensor node that we have having over here, and the other is wall sensor node. These type of sensor nodes are also a part. So different components associated with the sensors. Of course, we have the location finding system, some mobilizer, some power generator, some energy being supplied, and some sensors are definitely a part of the system. Some sensing unit, as well as it will involve some analog to digital conversion systems, processing units, where there is some storage management as well, and transceiver as well. So these are mainly defining the components or the sensor node components which we can. There are few researchers, both from computer science as well as electronics background, who are working on the optimal placement of the wireless sensor networks as well. So different components that we have just now highlighted, these are simply the elaborations in sensing unit. We have the processing unit, we have the transceiver unit, power unit definitely will be there. Of course, there are power generator or mobilizer or location finding system, which may be optional as a part of the sensor node network. So this is how it communicates. It communicates through satellite, communicates through your internet, communicate uh, with your system. So already we talked about this application layer, transport layer, network layer, and data link layer, and how we are controlling it through some protocols, some task management, some mobility management issues, some power management issues. How we are able to relate it with some applications related to application layer or transport layer or network layer or even your data link layer. So these are also a part of our communication protocol related to wireless sensor networks. A few of them we have it over here. Some sensor management protocol is there. Some sensor query and data dissemination protocol is also a part. So it provides some applications with some interfaces to issue some queries and respond to the queries, and also some sensor query and task language. Of course, it will involve some different language. So it will involve some different language and some directed diffusion or sensor MAC or SMAC, which we call it. some IEEE protocols definitely to take care of the different communication protocols associated with the wireless sensor networks. So these are some of the operating systems that are available. Mostly I'll discuss about Tiny operating system, Tiny OS. Quantiki is another, Mantis is another, Bitinut is another, SOS is another. So there are several operating systems. As we have a computer, we have a different, or in an embedded system, we talk about real-time operating system that we are mostly using in our smartphones. Of course, there will be some operating system associated with wireless sensor network, which we call as a tiny OS. So this to give you a glimpse about what it includes. It includes some scheduler, it includes some components, user components, some actuating and some sensing, or some communication part, and it may involve some hardware as well. So this is how it operates. This is how it operates, and this is just to give you a flavor and what are the characteristics. It must be having less amount of memory. It should be power efficient, and it should have been a concurrency in intensive operations as well. So, this is about some of the development platforms that you may. We have not worked on the sensor, wireless sensor networks too much, so we are also not very thorough with each and every technology that we are having. We have already given you the glimpse of the sensing node associated with Crossbow and WorldSense. So, of course, other enterprise networks are also there, like DAS networks or Sensorier Corporation or Ember Corporation are also there as a part of the different development platforms as well. So these are some of the simulators which are commonly used simulators in a wireless sensor network. So one of my fellow colleagues, he's from electronics background, and he's also having a diversified background consisting of electronics and computers. So he's working on sensor networks. So definitely, he will be a better person to use these simulators. I've just provided the names. Mostly, I do not work on the sensing, wireless sensing part, as I told you earlier as well. So these are some of the sensing networks. So obviously, you cannot be an expert of all. Just to give you a glimpse, just to give the audience a glimpse today about Internet of Things and a little bit about sensor networks, so that we are here for, and some of the emulators that we may sensing node or use of sensing node in a network, or some of the emulators that we have talked about. And apart from that, we have the hardware and the corresponding things. Sensing node is a part. We have discussed about processor, sensing unit, power unit, and trans receiver, and finally connecting to the antenna. So these type of things are also a part. This is another form of architecture where some operating systems are involved. Some mobilizer are involved. Some location finding systems are part of the system, and some mini applications or some communication networking, some communication radio or driver system must be there, and it has to be connected through some antenna as well. So these are some of the subsystems. We have the sensor drivers. We have the operating system, of course, which we call as microcode that is used with all the higher level things. Let me go back. Yeah, and sensor drivers are also a part, and communication processors, definitely the code management and the communication functions that are taking place, like topology maintenance as well as some medium access control as well. So communication drivers also involving uh, some sensors, sensor drivers, and communication drivers are also there. Data processing apps are also there, that you can control. So this is where we can think of developing some subsystems for a sensing node, and that's all I think I have to share for today's discussion on Internet of Things, as well as your applications. Of course, I've been telling you that we have been able to design a certain door buzzer that will also give you some security or something of that sort. So I think we can get over to Kamrul for further discussions, and we can have some question and answer from the participants as well. Over to you, Kamrul.
Thank you so much, sir, for your informative discussion. Thank you so much. I hope our participants learn a lot from you. Sir, today we have no quiz competition, so we are now going to our Q&A session. After a short video clips, we come back again. Okay, sir? Dear participants, this is our question and answer session time. You can send your question in our comment box. Our speaker are ready to answer the question. So if you have any question related this topic, you can ask the question in the comment box. Sir, our first question is, good afternoon, sir. Why is privacy and security important in law? And the second one is, what are the challenges associated with law?
Yeah, it's interesting, but perhaps I'm not the person who is uh, uh, Flummy Salvicho. I think we have not worked on the privacy and the security, but it is definitely important for your system to be dealing with data or any sensitive data that we are dealing with must be secured and privacy must be maintained because, of course, we are doing some, just as I told you, we are using some RFID tags for your smart devices that you are using. Definitely, if the privacy is not maintained, definitely it is a problem. So definitely it's a challenge, and we are working on cybersecurity and all those things are cropping up. It will be getting merged with IoT. So these are possible challenges. Definitely.
Thank you, sir. Our
I think
next
I can
question
see the
is,
next question, Kamrul. Uh,
yes, sir. The
I
next
have
question
read
is,
the
what are
question. What are the advantages and disadvantages? Yeah. Yes, I have read this question. Not an issue. Absolutely, I've seen on the screen as well. So definitely, we are able to communicate with certain devices, or say, I have forgotten to switch off my lights, or my phone is not connected to the internet, or my
Can you hear me, sir? Dear participants, there is internet connection in our speaker side. So we are waiting for our speaker.
I think there was some connection issue. Let me rewind it again.
Hello, sir. Can you hear me? Hello, sir. So we can go there. Okay, dear participants, our speaker led the platform. Because of internet connection problem in our country, we can't take our certificate code today. I just remind you that we will share this webinar and certificate code in our afternoon session. Because of internet connection problem, we can take our webinar today. So dear participants, for internet connection problem, we can take our certificate code from our website. We will share it in our evening session. Thank you everyone for your active participation in this session. Thank you everyone. Stay happy and stay safe.